Recommendations for electronic circuits prototyping. Use a 30-watt soldering iron to solder your component in your board. Use a soldering iron as sponge with water to clean the tip of the soldering iron. Use a good quality soldering wire to wire up your prototypes. Use a proper wire wrapping wire to wire up your prototypes. Use soldering fume extractor to protect yourself from the fumes of the soldering wire. Use a good quality tin coated wear board for your prototyping. In our previous session, we have written a program to control the status of the relays, that is relay 1 and relay 2. We have implemented a command to control the status of the trike. In this session, we will write a program to read the status of the 4 switches which we have connected on port D of the microcontroller, that is from port RD4 to RD7. We will implement a command to read the 4 analog channels of the microcontroller, that is from analog channel 0 to analog channel 3. We will also implement a command to control the duty cycle of the PWM signal, and we know that we have converted the PWM signal into analog voltages and will measure the varying voltages at the analog output port of our RTU. And here we have our next command to read the status of the switches which we have connected on port D from port RD4 to port RD7, and we can see from the schematic that the logic of these switches is active low. Before writing the subroutine to read the status of the switches, first we will define a flag, that is switch flag. So here we will define that is SHWFLG, and we will initialize the switch flag in our main routine. And now we'll write the subroutine to read the status of the switches from the RTU. So here we will write that is switch read routine, and we will write the switch read routine before main program. So here we will write, and here we will write the switch read routine, that is void and we'll write the switch read routine between these two braces. But before writing the switch read routine, we will set the switch flag in our serial read routine. And here we'll copy these 3 lines from our previously written program. So we'll copy these 3 lines from here, Ctrl C, and we'll paste and modify these lines for our new subroutine. So here we'll paste these lines, Ctrl V, and we'll replace these 3 characters with SHW. If the first 3 characters of the received string will be compared with SHW, then the value of the integer, that is test string, will be 0. And here we'll set the switch flag, that is SHW. And now we'll write the switch read routine. And here we'll check the status of the switch flag, that is if switch flag equals to 1, then our program will come into this if condition. And here we will read the status of the port D in a register, that is switch register. And here we'll define a variable, that is switch register. So here we'll define that is unsigned character, that is SWREG equals to 0. And now we'll read the status of the port D in switch register. So we'll copy this variable from here, that is Ctrl C, and we'll paste a variable here equals to, and here we can check we have defined the port D as switch port. So we'll copy this assignment from here and we'll paste the assignment here, Ctrl V. As we know that all 4 switches are connected with the upper nibble of port D, so we'll mask the lower nibble of the port D, and here we'll use AND logic to mask the lower nibble of the port D. So we'll write that is AND. Here we have masked the lower 4 bits of the port D, and we have moved the value of port D in switch register. From the schematic of the switch interface circuit, we can check that we have connected 4 switches from port RD4 to RD7, that is the upper nibble of port D, and we have read the status of the port D in a variable, that is switch register. If no switch will be pressed, then the status of the port D can be written as, that is SW register will be, which is the upper nibble of the port D, and the status of the lower nibble of the port D is don't care. Because in this program we are not interested to read the lower nibble of the port D, so we can write the status of the lower nibble of port D as and we have performed AND operation with port D with F0 to mask the lower nibble of the port D. So here we can write that is which is equals to F0, and it will give us the result that is and now we'll rotate right the switch register 4 times to move the higher nibble of the switch register to the lower nibble. So we'll perform a rotate right operation 4 times, that is rotate right 4 times. This operation will move the higher nibble of the switch register to the lower nibble, that is and now we'll XOR the switch register with a number that is 0F to convert the all 4 high bits to the 0. So here we'll perform the XOR operation with switch register with 0F, that is 0 0 0 and 1 1 1 1, which is equals to, and in this case if no switch will be pressed, then the value of the switch register will be 0. So we'll get the number that is equals to 0, and if any switch will be pressed, then the corresponding bit will be 1. So we'll implement the same logic in our program to read the status of the switches, and here we will write that is switch register equals to switch register rotate right 4 times, and now we'll XOR the switch register with the number that is 0F. So we'll write that is switch register equals to switch register XOR that is 0F. So here we have converted the high logic of the switches to the 0 logic, and now we'll convert the number that is switch register to a string, and we'll send back the string from the microcontroller to the USR terminal of micro C. And here we can find we have declared a variable that is data string. Now we'll go to the help, we'll go to the micro C Pro for pick libraries, and here in miscellaneous library we'll go for conversion library, and here we can find a conversion prototype that is byte to string, and here we can find in sample program that how to use this prototype, that is byte to string, the number and the text. So we'll use this prototype to convert the number into a string. So we'll copy this prototype from here, and we'll use this prototype here in our switch reroutine, and we'll replace the first variable with the register that is switch register. So we'll copy this number from here, Control C, and we'll paste it here, and here we can check we have defined a variable that is data string. Now we'll replace the second variable with a variable that is data string, and in system libraries we'll select the conversion library, and now we will write the data string to the serial port, and from serial read routine we'll copy the prototype that is UART1 write text. So we'll copy this prototype from here, Control C, and we'll paste the prototype here, and we will replace this variable that is receive string with a variable that is data string. After sending the data string to the serial port, we'll clear the status of the switch flag. So here we will write that is switch flag equals to 0. Now we'll compile the program and we'll observe the result of our program on our prototype. Now we'll send the command to read the status of the 4 switches from the USR terminal of micro C. And now we'll send the command to read the status of the switches, that is SHW. OK, send. Here we can check we have received the number that is 0. Now we'll press switch 1 and we'll send the command once again. OK, send. Here we can check we have received the number that is 1. Now we'll press switch 2 and we'll send the command once again. OK, send. Here we can check we have received the number, that is 02. Now we'll press switch 3 and we'll send the command once again. OK, send. Here we can check we have received the number, that is 4. Now we'll press switch 4 and we'll send the command once again. Here we can check we have received the number, that is 8. And now send the command once again if no switch is pressed. OK, send. Here we can check we have received the number 0, it means no switch is pressed. We have implemented the command, that is shw, to read the status of the switches.